Alright, young'uns, welcome to the final lesson for our matrices unit. We'll be covering two chapters in this one because they're more or less related to one another. So 5J and 5K will be covered in this chapter. So this is our last one. Alright, now just a recap of last lesson. You would have, or I'm expecting you would have watched the video and done the work for chapter 5I on encoding and decoding information. That in some ways will help, as well as the previous exercise of 5H, the inverse matrices. That will help in understanding how to do 5J. So if you haven't watched H and I would highly suggest that you do that because they will be of a lot of help. Okay. All right, let's get into it. So 5J is focusing on solving simultaneous equations using matrices. Now, you will have at some point come across a simultaneous equation. Generally, in year 10, you would have done a little bit of it, but it's not such it wasn't a big thing back then. Back in that in that topic. But in here, it will be a little bit more in depth. But don't feel as if you can't do them because it's mostly calculator work anyway. So solving simultaneous equations, but using matrices is the focus. Now, before I actually start going through any of this, I want to just quickly recap on some things to help you give you an understanding of how all of this is going to work, to understand, to figure out, to help you understand all of that. So, if you remember back to last year, you would have come across something called an inverse operations. Okay, inverse operations. Okay, and what that basically means is you use inverse operations to find unknown variables. That'll be the same case here. Okay, but using inverse operations to find unknown variables. Now, you actually should already know what the word inverse means. Okay, but just to dumb it down a bit and to go back to what we would have learnt last year, if you have something that is being added on one side of the equal sign, the inverse of addition is going to be subtraction. So inverse is basically saying what is the opposite, or what is the opposite value of that that number or that term. Okay, the opposite of minus or subtraction would be addition. Okay, the opposite of multiplication would be division, and the opposite of division would be multiplication. So let's put some of that into context. Let's say you've got like 2x equals, let's say 12. So in this case, this is saying 2 times x equals 12. What is x? And you want to try and isolate or make x by itself, so you have to get rid of this 2. Okay, and put it on the other side. Okay, now, with the inverse operations, whenever you're moving a number from one side to the other, you have to change it to its opposite inverse, or to its inverse operation. So if it's being multiplied on this side, this is a multiplied by 2. So if I move that 2 over to the other side, let's go this way, sorry, move it to the other side. So it's multiplied by 2. The inverse of multiplication is division. So that means it becomes divided by 2. So now solving that, you are left with x equals 12 divided by 2 is the number 6. 2 times 6 equals 12. And that makes sense. Okay, let's try one more. And because the main focus I want to really look into is just these two inverses, yeah? And how that relates to what we're doing. So actually, probably not even those two. More so just this one. But anyway, let's try another one. Let's try x over, let's say, oh no, sorry, let's go, yep, x over, let's say, 10 equals 5. Okay, so something divided by 10 equals 5. So what's that something? Remember, with the inverse operations, and whenever you, sorry, before I even say that, with this sort of equation, you want to try and isolate x, make x by itself. So you want to make sure you move any number any number away from this side of the equal sign to the other side. So this is a divide by 10. So when you move that over here, the inverse of divide is multiplier. So now it becomes multiplied by 10. Therefore, x equals 5 divided by 10, 5, sorry, multiplied by 10, which is 50. Okay, so x is 50, and you can prove x that equals 50 by putting x back into the formula here. So 50 divided by 10 definitely equals 5. Okay, so that's how your inverse operations work. The idea is you want to try and isolate the unknown variables to figure out what it is. Okay, now to bring that back into this part of inverse operations, we're going to look at how inverse operations work with matrices. Okay, and we already know what the word inverse means. If you look at 5H, 5I, we used inverse matrices there for 5I we used it to decode a message. Yeah, so you had to get the inverse of a matrix, and then you multiply it with the secret code, and it brings it back to that point. And you also, in the previous chapter of 5H, we found out how to calculate an inverse matrix. And think of an inverse matrix, remember, as the same. It's just the opposite of a matrix of itself. Like I think I made a analogy with anyone seen Stranger Things, like the underworld type thing. Yeah, so it's basically the opposite of that matrix. So in this case, solving for x in the following situations, we know. So for example, in this example, a times x equals b. So if you want to isolate x, make x by itself, this is saying a times x, yeah? So when you move it to the other side, okay, it becomes divide, right? But, okay, when it comes to inverse operations of matrices, instead of dividing, okay, you're actually just going to go inverse. All right, you're going to change a into an inverse of a, and then multiply it with b. Okay, so instead of dividing or dividing for inverse matrices and figuring out the unknowns, okay, all you have to do is literally move that a, whatever matrix a is, to the other side, make it an inverse, and multiply it with b. Okay, so that's what all this is saying. All you have to do is move that a, okay, make it an inverse, and multiply it with b here. See that? That a it was taken care of. It's gone now. It's put here. It's become an inverse of a times b. That's all it is. Okay. So to figure out these inverses, again, the idea is you want to isolate the unknown variable. Okay, isolate that unknown variable and put that in matrix. So say for example, I'm trying to look for what x is. So I want to isolate that. Move that a, bring it here, and make it an a inverse times whatever that matrix is for b here. Okay, that's what it's saying. Generally, what you want to do, I think for most of these questions, just make sure you understand where the a inverse matrix is going to be. If it's at the front like this, ax, make sure when you put it on the other side, it's going to be a inverse times b. But if the unknown is on the left-hand side, make sure you put that inverse on the right here. Okay, just the general rule. I don't think this matters too much though. But I think most of the stuff that we'll do is going to pertain to this. So putting it in the front. So a inverse times b is going to be the case. But let's actually put some of this to practice so we can get it going. All right. So here you'll need your calculator for this. I might also use the app as well at some point. The app that is online that I showed to you guys before. So for this first question here, we've got matrix A and matrix B. So matrix A is a 2 by 2, so is matrix B. And we need to solve for the unknown matrix F, which means in both of these equations, we need to isolate X, make it by itself, and just move that A matrix to the other side. Okay, so let's do this one first. Question 1A, that's going to be AX equals B. And it's saying solve for the unknown, which is X. So we have to make X by itself. Now, in order to do that, we know that we need to move that matrix A to the other side. So if I move that matrix A to the other side, it now becomes A inverse. Okay, remember A inverse is denoted by this, A to the power of -1. So what you're left with is this. X equals A inverse times B matrix. Okay, that's all it is. So let me rewrite that, because remember you're trying to figure out what matrix X is. So I'll rewrite that step here. So matrix A we know was this matrix. What was it? Yeah, so 2, 5, -1, 3, multiplied by matrix X equals whatever B matrix was, which is B matrix 16, -3, 3, and then 7. Oops. Okay, so that's the first part. And then the second part was we moved that A matrix, so this guy, moved A matrix, brought it to the other side, made it an inverse, and then multiplied it by the B. So that means when you do this, matrix X is equal to whatever A inverse is times by the B matrix, which I remember was 16, -3, -3, 3, and then 7. I'll use the online version for this one, yeah, so you guys can actually have more than one way to do this. So remember, when you have the online version of the matrix calculator, always start off by just naming your matrix first, so then you get new matrix. It'll always make it a 2 by 2, which is ideal because generally that's what you'll have anyway. So you've got 2, then you'll have 5, then we have -1, and we have 3. So there's A matrix, and then you want to make B matrix as well, yeah? So B matrix, so click on B, new matrix, put the numbers in, 16, -3, 3, and then 7. So there's A matrix, B matrix. So to figure out what X is, we have to inverse the A and multiply it by the B. So I'm just going to add a couple steps with this one, but you don't necessarily need to do this. But for A, to find A inverse here, you literally type, or you click the letter A, because we already know what A is, and then this to the power of -1. And there is my A inverse. Now if you click on this, it does change it to a fraction, which is awesome. Okay, so let's put that in here. So we've got 3, 11, 3 over 11, so they're all over 11. Let me just put that in here. Oops. So you've got 3 over the 11, -5 over 11. Do prefer the fractions in this case because they're just easier to write than a bunch of decimals. 1 over 11, 2 over 11. Okay. So excuse the horrible matrix. Let me just rewrite it. I didn't expect it to be this big. So let's just fix that. So this is the A inverse matrix right here. And this is the B matrix. So now we just multiply them together, which means that matrix X, so let's put that all together in our calculator. So it's going to be A inverse, whoops. So you can type in A inverse multiply by B matrix, which equals there. 3, enter. Oh, yeah, that is the answer, sorry. 3, -4, 2, 1. Therefore, matrix X, doesn't like me, is 3, -4, 2, then 1. It's that easy, guys. That easy. Okay. Let's go to the next one, and we'll see how. All right, so that's that question. Sorry, guys. Let's go to the next one, which was AX equals 13. Well, this matrix. Yep. Remember, in this equation, we're trying to isolate X, make X by itself. So that means we've got to move this A over to the other side. And remember what happens to the A when you move it to the other side? It just becomes inversed, and you multiply it with whatever that matrix is there. All right, so let's write that here. So you've got AX. So this is saying A times X equals this matrix, 13, 1. All right, and then so if you want to isolate that X, get rid of the A. When you move that A to the other side, it becomes A inverse multiplied by that matrix. So you're left with this. X is equal to A inverse, whatever A inverse is, multiplied by 13, -1. Okay, so let's figure that out. Really easy, yeah? It's the same process as this. Actually, let me just write this for you guys as well. Let's go blue. So that means x matrix is equal to A inverse. Remember what was A inverse? Actually, I don't even need to rewrite that. My bad. I'm going to just go straight down here. X matrix is equal to A inverse. And we found what A inverse was. Remember on our app? Calculator app right here. A inverse was this. Oh, let me just write A inverse. Oops. Studio, just write A in. There it is. Okay. A inverse is that, but if you click on this, it changes it to a fraction, which is a lot easier to work with, I would say. So A inverse was that matrix right here. 3 over 5, 3 over 11, sorry, negative 5 over 11, and 1 over 11, and 2 over 11. So that means x is equal to A inverse times that matrix, 13, 1. So therefore x is, let's put that in our calculator. So we'll make a new matrix here. I might call it matrix C. Oops. And then we'll decrease the number of, what was it? I think it was a 2 by 1. So 2 rows, 1 column. And it was 13 and negative 1. So 13, negative 1. So that's C matrix. So we're going to go A inverse multiplied by matrix C, which is that matrix there. So we get 4 and 1. Therefore, the value of that is 4 and 1 of X matrix. All right, easy. Easy, easy, easy. Let's go to the next part, which is solving these equations, or solving simultaneous equations using a CAS calculator. Now, that will also cover into 5K. So I think, like I said, I would like to just do this whole video into the one question. So one whole video. So, all right, let's go through this one. Now, when it comes to solving your simultaneous equations, okay, that means there's more than one equation. Yeah. So if you look at this question, you've got two equations: equation 1 and equation 2. Now you'll see how all this applies later on when we do this example. Yeah. But you have two equations here. Now, what you have to do is actually turn these equations into matrices, and they're pretty easy. You have to break them up into 3 matrices. Okay, so you got to break it up into your number matrix. Okay, what's the number matrix? The letter matrix. Don't be scared of these. These are really easy to do. And the answer matrix. That's how I sort of teach this. So you break it up into 3 matrices: number matrix, letter matrix, answer matrix. Because if you look at each of these equations, there are these numbers, there are these letters, and then there's the answer. So you got to break it up into those 3 matrices. But you have to incorporate the whole thing. So let me rewrite that: 5x plus 2y equals 21. And the other equation was 7x plus 3y equals 29. Okay, so for this sort of question, it's going to ask you what is x and what is y. So in order to do that, break it up into the number matrix, the letter matrix, and then the answer matrix. So let's break this up into those 3 matrices. So in terms of the number matrix, okay, but actually before I start, you're gonna know in this this matrix, it's gonna have 2 rows because there's 2 equations. Okay, so if you had 3 equations, then you'll have 3 rows. In this case, there's 2 rows, so we'll just break it up into that. So this is for my number matrix. Okay, this is my number matrix. Now all you got to do is list out the numbers that are in these 2 equations. So how many x's are there? Well, there are 5 x's, so that's the first one. So the first row, first column here represents all the x's. Okay, and how many y's in that first row, first column? Sorry, the first column here. I'm not sure if I said row or column. First column here refers to all of the x's. Yeah. Second column will refer to all the y's. First row here refers to the first equation. Second row here will refer to the second equation. Okay, so how many y's are in the first row? There's 2. How many x's in the second row or second equation? Well, there's 7 x's. How many y's in the second row? There's 3 y's. Oh, there's 3 y. They're not 3 y's, but there's 3 next to the y. So there's my number matrix. The next part, so now you write multiply, is the letter matrix. Now this is really easy. You just got to write down what are the variables that are here. Well, we have x and y. So remember, this represents the first equation. This is the second equation. All you have to do is literally write down what are the letters that were used here. So you have x and y. Because remember, you're trying to figure out what is the x and what is the y variables. Okay, and then the next part is what's the answer matrix? So equals, what was the answer? Well, again, you're just breaking this up into 3 matrices. The letter matrix, a number matrix, letter matrix, and this is the answer matrix. This is how I sort of explain it to my kids. But the answer matrix here, just those 2 numbers, 21 and 29. Okay, now, you can probably see what's happened here. Okay, it's actually quite similar. Okay, let me just zoom out a bit. Similar to what we've been doing here. And it's the same process, okay? You can think of this as the number matrix, letter matrix, answer matrix. And you can see that all you have to do is now get the inverse of that number matrix, bring it to the other side, and then multiply it with the answer matrix. So let's do that. It's the same principle here now. What you're going to do is get this whole matrix, inverse it. Okay, so you get the inverse, and then multiply it with that matrix there, times that matrix right here. This one. So what you're left with is this. Let's just write out the whole thing so no one's confused. And just zoom in on this. Okay. So what you're left with is this. Because remember, you're trying to figure out what is the x and what is the y variables. X, y equals. So now we have to find the inverse of that matrix. So let's do that. The inverse of this matrix here. Oops. Let me just get rid of all this. This is a new question. So we can make a new matrix. We'll just call this matrix A if you want. Okay, you can call it whatever you want. But matrix A is a 2 by 2. We have 5. Alright, sorry about that, guys. Okay, so I'm trying to find the inverse of this matrix, yeah, and I was halfway through it. Let me just get my trusty calculator. So 5, 2, 7, and then 3. Okay, there's my A matrix, right? So if I find the inverse of A to the power of -1, there's my matrix, then my inverse of that matrix. So it's 3, -2, -7, 5. So if I inverse that, 3, -2, -7, and 5, I think it was. Just double make. Yeah. So remember, this is my number matrix, a letter matrix. This was my number matrix, but now I've inversed it. Multiply by that answer matrix, 21, 29. Okay, so that means x and y variables. So the x and y variables are equal to, well, let's just multiply them. So this matrix, I wonder if I can, there's a short way of doing this. No, okay, there isn't. So it's going to be A inverse. Remember, this is the inverse matrix. A inverse multiplied by this matrix here, yeah? So in that case, multiplied by times. Okay, in this case, I do have to write down the actual matrix for it. Let's call it matrix B. Okay, 21, 29. I think that's the annoying thing with using the app version. It's going to be A inverse multiplied by matrix B, which equals 5, -2. So that means the x and the y variables are 5 and -2. Okay, so it'll ask you what's the x and y variable, and that's that, 5 and -2. And to do that on your calculator, well, we just did it. Okay, it's pretty straightforward, yeah? So it's the same principle. For all of these questions, when you do simultaneous equations, break it up into your number matrix, letter matrix, answer matrix. And I've done that here. So your number matrix, what are the numbers in each variable or each equation? Remember that each row represents an equation. Yeah. So in this case, because there's two equations, there's going to be two rows. Each column refers to the number that is next to each variable. So that means in this case there are 5. There's a 5 next to the x. There's 2 next to the y for the first equation. And then you've got 7 x's and 3 y's there. And then here, letter matrix, she's breaking it up into what are the 3 letters or 2 letters that you have, or the 3 or 2 variables that you're looking for. In this case, you're looking for the x and the y variable. Yeah, so x, y, there's only 2. And then the answer matrix is basically the answer for each equation put into a matrix there. All right, let's do some examples from 5K because this is all connected anyway. This is now the same principle, okay, as this, but now you have 3 equations. So here, same principle of make it into a number matrix. So break it up, into a number matrix, the letter matrix, and then the answer matrix. That's sort of the easiest way I can explain how all this works. So in this equation, let me just write it here. So x minus 2y plus z is equal to -2. That's the first equation. -2x plus 3y equals -3. And then you've got 2x minus z is equal to 4. Okay, so let's break it up into a number matrix, letter matrix, answer matrix. Okay, now you might be finding this one a little bit tricky, but it's not that bad. Okay, we have 3 equations, so you're going to have 3 rows. Okay, we also have, if you look how many variables we have x's, we have y's, and we have z's. So we have 3 columns as well, because there's going to be 3 variables to look for. Okay, so for the first equation, okay, how many x variables are there? In this case, there's only, remember, in front of every letter by itself, there is 1 x. So that means for the first number on our first equation, there's only 1. How many y's are there? Well, there's a -2. So paired with the y, there's a -2. And how many z's are there? Where there is 1 z in front of that. So there's a 1 in front of that z. So that means we put 1 for the z in that first equation. Yeah. Second equation, there are -2 for the x. Y, there's 3 of them. Okay, now z, it's non-existent. So that means for the z, in the second row, for the second equation, we put 0. Okay, there's no z's there. And then for the third equation, we have a positive 2 paired with the x. We can see that there is no y in this equation, yeah? So that means there's going to be 0 for the y, and we have a -1 for the z there, so -1. All right, so there is my number matrix for that. Letter matrix, remember there's 3 variables here. So it's just going to be x, y, and z. And then your answer matrix, okay, it's just the answers for each of these equations. So -2, -3, -4. Okay, and then it's the same exact process, okay, for this one. So you're going to get that inverse of that matrix, put it on the other side, and multiply it with the answer matrix. Right? Same exact process. So get the inverse of that matrix, put it on the other side, multiply it with that matrix. So let's find the inverse of this matrix here. So your equation is going to look like this. Yeah. So remember you're trying to find the x, y, and z variables. X, y, z is equal to whatever the inverse of it was times that answer matrix. So -2, -3, and 4. Sorry, I did write -4 there, didn't I? Let's fix that up to just be 4. Okay, so let's use a trusty calculator to find the inverse. On your CASs, by the way, if you want to find the inverse of a matrix, you're just going to put it to the power of 1. Okay, that's all it is, to the power of 1. Now, on the online calculator, it's a lot easier to do, yeah, but yeah, that's that. So let's make a new matrix. This is going to be a 3 by 3 3 rows, 3 columns. So make sure you increase the rows and the columns here. And the matrix has 1, negative 2 is 1, negative 2, 3 is 0. Then you have 2, 0, negative 1. Okay, that's a matrix there. Easy. And then we'll make an answer matrix here. It's a 3 by 1. So 3 rows, 1 column. We'll just call it matrix B. 3 rows, 1 column. So negative 2, 3, and oops, and then 4. Okay, so that's B matrix. Remember, the process is inverse that matrix when you bring it to the other side. All right, so you want to inverse, get the inverse of this, bring it to the other side, and then multiply it with that matrix. So in this case, when I inverse it, this is the inverse of that matrix. Oops. So that'll be a matrix A, I've called it. Okay, so it's going to be A inverse. On your calculators with your CASs, it's just to the power of negative 1. So in this case, you've got 3, they're all over 5, 3, 2, 3, so 3 over 5, 2 over 5, 3 over 5 for the first row, 2, 2, 2, 3, 2. No, okay, why did I write all of them over? Okay, let me fix that, sorry guys. They're all over 5. My bad. Audio's going crazy. 2 over 5, 3 over 5, 2. Okay. Ah, man. You can probably skip this if you want to. Okay, horrible writing. And then the last row, 6, 4, 1. So 6 over 5, 4 over 5, and then 1 over 5. Okay, so we're going to inverse that matrix and then multiply it with the answer matrix to get what x, y, and z are. So the x, the y, and the z variable. So write your answer like this: x, y, and z variable is equal to, okay, it's going to be 3 by 1. Okay, so that means A inverse times B matrix multiplied by matrix B right there is equal to 0, negative 1, negative 4. So x is 0, y is negative 1, z is negative 4. 0, negative 1, negative 4. All right, let's do one final example of this, and then we can, you guys can start your exercise. All right, so this is the example for 5K. A bakery produces 2 types of bread, wholemeal, rye, and rye. The respective processing times for each batch on the dough making machine are 12 minutes and 5 minutes, while the oven baking times are 16 and 12 minutes respectively. How many batches of each type of bread should be processed in an 8-hour shift so that both the dough making machine and the oven are fully occupied? Now, this is a pretty involved question because there's a few things that you need to think about when you figure out what the x and y variables are. So we need to determine the batches of wholemeal bread and the number of batches of rye bread to make. So basically, what this is asking is how much bread, so how much wholemeal and how much rye should you be making, so that over a span of 8 hours, okay, over the span of 8 hours, you'll be able to use the machine without stopping. Okay. Now, a couple of things to think about here is it's told us what the x and what the y variable are in terms of what they actually really mean. The x variable, so the x refers to the wholemeal, okay, and the y variable refers to the rye bread. Okay, so we need to figure out how much wholemeal bread, okay, how much wholemeal bread and how much rye bread can we actually make in a span of 8 hours. That's what it's asking. And it says here, according to this question, in one batch, so for the dough making machine, for the dough making machine, it takes 12 minutes for the wholemeal bread, and then 15 minutes for the rye bread. Okay, 12 minutes for the wholemeal. So this is going to refer to the wholemeal bread. Okay, and the 16 minutes refers to the rye bread. Okay, let me just put that. Yeah. Remember, wholemeal is denoted now with X, and rye is going to be Y. Yes, so we don't have to write wholemeal and rye each time, just X and Y. Oh, sorry, I just underlined the wrong one. This one here, sorry, is the rye. And then the oven baking times. Sorry, I read that wrong. In this case, the oven baking 16 minutes refers to the wholemeal, and it takes 12 minutes for rye to be baked. Okay, and they both need to equate up to an 8-hour shift. Okay, so that means both machines need to be running for 8 hours. Now, the interesting thing with that is because this is in hours and these are in minutes, we need to convert 8 hours into minutes, okay, before we start working. So 8 hours into minutes. Now, this is probably one of the harder questions that you'll come across because there's a few processes involved, but hopefully you guys will be okay. So 8 hours into minutes, so 8 times 60, so 6 times 8 is 48. So that's going to be 480. Okay, so over an 8-hour process, this shift, you need this whole thing, or both of these equations will be going for 400 up to 480. Okay, so let's rewrite the equation. First and foremost, you want to write the equation for this. Yeah, so let's do the equation for the first part there, the wholemeal. So for the first part there, let x represent the number of batches for the wholemeal bread, and then let y represent the batches for the rye bread. So that means for the first part, you know that it takes 12 minutes, okay, for one bit of wholemeal to be made, okay, to be I guess mixed in the dough making machine. So that means for the first one, it's going to be 12x. Okay, 12x. So this should, this should be 480. Okay, 12x is the first part. 12x, and the second part of that question is basically now, okay, 12x plus, okay, plus how many minutes for the rye bread for the dough making? It's 15. So 15y, and that should equal 480 because you want it to go over the whole 8-hour process in the that dough making machine and oven thingy. All right, and the next equation, so the second half of that is going to be 16 minutes for the wholemeal, so 16x, it takes 16 minutes for it to get baked, plus 12 minutes for the rye bread, and that should also go for 480 minutes. Now you can see here I've got my two equations. I think the trickiest part of any question like this is actually coming up with the equation, because doing the process to get the answer is pretty easy because it's the same thing. Break it up into the number matrix, the letter matrix, and the answer matrix. All right, so let's break that up into the number matrix, letter matrix, answer matrix. All right, so for the number matrix, it's two equations, so there's going to be two rows, and I can see there's two variables. X refers to the number of wholemeal, Y refers to the number of rye bread. So in the first equation, there is 12 of the X's, and there's 15 of the Y's. There are second equation, there's 16 of the X and 12 of the Y's. And then multiply that by, okay, the next part is make the letter matrix. Your two variables are X and y. You're looking for the x and the y variable. And that equals 480 for both of them. Okay, 480. Because they both need to run for 8 hours, right? And we've gotten that 480 from the shift. The shift is 8 hours long, so we have to change it to 480. Okay. And it's the same process, yeah? Put this on the other side, inverse it, multiply it with that matrix there. So to get the x and y variable, get that inverse of that matrix, multiply it with the answer matrix. Okay, let's just get a calculator out. So let's clear it all. In this case, this is a 2 by 2, so we've got 12, 15, which is my thing, 16, and 12. So there's matrix A, and then we'll make a new matrix. We'll call it matrix B. This is a 2 by 1. You'll notice that the answer matrix is generally just a row matrix, yeah? So 480, 480. Okay, so we're going to inverse the A, yeah? So A inverse equals that. Change it to a fraction if you want. So negative 1/8. Ooh, these are ugly numbers. 5 over 32. And then you've got 1/6 negative 1/8. Okay. Remember, this is the inverse, yeah, of that matrix there. So if this is A matrix, let's do that again. If this is matrix A, I've brought it to the other side. This is now A inverse. All right, so when you multiply that, so A inverse multiplied by times B matrix, which is that one, you get 15 and 20. All right, let me write that here. Equals 15 and 20. So what does that tell us in the context of the question? Remember, X represents the number of rye bread, a wholemeal bread, sorry. Y represents the number of rye bread. So that means in order for us to be able to make use of the machine over the 8 hours, we need to make 15 batches of the wholemeal bread and 20 batches of the rye bread. Okay, so I'll write that as an answer. In order to make full use of the machines over 8 hours, we need to make, so how much of each bread do we need to make? We need to make 15 of the X. Remember, X represents the wholemeal. So 15 wholemeal. And how much of the rye? We need 20, I think it was, 20 rye. And that's it. I'm hoping this has made sense to you guys and that this will help you all. But go ahead and finish 5J and 5K. Thank you.